This is 7.4, inverse functions. So we've talked a lot about functions, and now we're going to talk about a function's inverse. But we need to talk about what a relation is first. A relation is a mapping of input values to output values. If you have exactly one output per input, we call that a function. And that's what we've been talking about all up until this point. If it's a function, it also passes the vertical line test. An inverse relation is outputs to inputs. So when you're finding an inverse relation, you're going to switch x and y and solve for y. The domain and the range are switched. And I'll make all this make sense. The last thing that happens with an inverse is the graph is going to be a reflection over y equals x. All right, so let's start off with the relation, and we'll see if we can't find its inverse and graph it. So let's start with the relation. And the relation that we're going to have is y equals 2x minus 4. So I'm going to go over here, and I used graph paper today just so you could see. So I'm going to start by graphing y equals 2x minus 4. So I'm going to go down to negative 4 and put a point. Then I'm going to go up 2 over 1. So that kind of looks something like this. I have the point 0, negative 4. I have the point 2, or excuse me, 1, negative 2. I have the point 2, 0. I have the point 3, 2. And so on. All right, let's find the inverse. So to find the inverse, we're going to use our relation and we're going to switch the x and the y. Now we're going to solve for y. So I'm going to add 4 to both sides, and then I'm going to divide everything by 2. So I have 1/2 x plus 2 equals y. So this thing was a function to start with, so I could have written it like this. This is also going to be a function because if I graph it, and I'm going to graph it using pink pen here, I would start at 0, 2, and I would go up 1 over 2. So this would be the point 2, 3. Up 1 over 2. Up 1 over 2. Down 1 over 2. So this would be negative 2, 1. Down 1 over 2. Negative 4, 0. So this thing also passes the vertical line test. So since the relation was a function and its inverse is also a function, I can write this one like this. This could be y equals 1/2 x plus 2, but because it just happens to be the inverse of the f function, I can write it like this. So when you see that, it kind of looks like a little negative 1 power, but what that means is this is the inverse of this. Now let's look at the graph. If I jotted in, and I'm going to jot in the line y equals x, this is every point where y and x are the same. Notice that each point on this black line is a reflection of one of the points on the pink line. Notice on this first one, my function, I had the point 3, 2. On the inverse, I had the point 2, 3. Here I had 2, 0, here 0, 2. What was this one? 1, negative 2. Here it's negative 2, 1. So notice every point on the function and on the inverse of the function has the x value and the y value switched. So let's say I knew that I had a function that was x plus 4. Well, if the point 1, 5 is on this, then I would know that on the inverse of that particular function, I would have the point 5, 1. Because you'll always have the x and the y switched when they're inverse functions. All right, let's do another one where we have to find the inverse. So let's do y equals negative 3x plus 9 over 5 and see if we can't find the inverse. So this is a function, so I can write it like this. And now I'm going to find the inverse. So I'm going to switch the x and the y. So x equals negative 3y plus 9 over 5. So to solve, the first thing I'm going to do is multiply both sides by 5. So I get 5x equals negative 3y plus 9. Subtract 9 from both sides. And divide everything by negative 3. So I get negative 5/3 x plus 3 equals y. This is also a function, so I'm going to say the inverse of the function is negative 5/3 x plus 3. This means that whatever point I have on here, I'm just going to make this up, so whatever point I have on here, x, y, well, those are going to be switched. And whatever that number is going to go here and here.